All right, this is section 6.2 in your textbook. Everyone has their sheet out because we're going to be correcting this. If you do not have the questions done, just make sure you copy them down as quickly as you can. Or, of course, alternatively, if you miss something as you're copying it down, just watch the video because it will be posted, of course, on YouTube because that's where you're watching it. Question 2 is the first question we did. It says, Grace says it would be reasonable to interpolate values on these graphs. So if you are interpolating, what you can do is you can connect the dots and you could read between them. So the first one, this one here, no, it is not okay to interpolate. And the reason why is you cannot buy half a carton of ice cream. You cannot go to the store and say, I would like to buy 1.5 cartons of ice cream and it would cost you $6. Impossible. So because you can't buy half cartons, the answer is no. But the second question, if I connect my dots and go in between them, it is likely possible to pay for 1.5 kilometers of a taxi ride, or whatever this happens to be, because you would not charge simply by the full kilometer, but it is possible for half kilometers. So we could say it's reasonable that you could be charged for partial kilometers traveled. In the third question, it says develop a situation that involves a linear relation. Now, since all of ours are different, I'm just going to make up one. So if I was to put down C for cost in dollars, $1, $2, $3, $4, and then I was to say 3, 6, 9, and 12, and we'll call these apples. A. I should put my apples down here. Erase that. And call this A. Then if one apple costs $3, 2 apples cost 6, 3 apples cost 9, that would be a line. Now, is it possible? Sorry, 3 apples cost $1. I got that backwards. $1 for 3 apples, $2 for 6, and $3 for 9. Is it possible to interpolate this one? Is it possible? Is it reasonable for us? Is any point in here possible? Or is it limited to certain numbers? Can you buy part of an apple? Can you buy 1 1/3 of an apple? No. You cannot buy 1 1/3 apples, but you can buy 4 and 5 apples. So these points here are okay to interpolate, but not partial ones in between here. You can't buy 4.5 apples. So because you can't, certain points are, but not all points. Question 4 says the graph shows a linear relation between distance and time. What is the approximate value of the d coordinate, or distance, when the time is 5 hours? So if we go up from 5 and we go over from here, we would say the rough distance is maybe 14 kilometers or so. So we use the approximate symbol or the wavy line for equals, approximately 14 kilometers. And the second part says, what is the approximate value of the t coordinate when the distance is 20? So we go over on our distance to 20, come down, and therefore the time would be 7 hours, approximately. Question 5 says the graph shows a linear relation. What is the approximate value of the y coordinate when the x is negative 2.5? So negative 2.5 would be here. If I go up here and over, I would say it's roughly y is 14. And when y is 4, we have it here. What's the x value? Go over to here. The x value is roughly 1.5. Yeah. Question 6, the graph shows a linear relation. What's the approximate value of the y coordinate when x is 1.5? So when x is 1.5, that's right there. Go down until it meets. We'd say y is approximately, or equal sign with a dot above it, negative 3.5. And when y is 0.5, 0.5, what's the x value? The x value would be roughly negative 1.5. An equal sign with a dot above it means approximately equal to. Question 7. The table of values represents the distance that Sophie cycles in relation to time. So it says plot the relation on a graph. So for our graph, we're going to have a T and a D. Now the T here is 1, 2, 3, 4. So I'm going to make this axis T, and I'm going to put 1, 2, 3, 4, 5. So this is going to be time, and in brackets we're going to say in what types of units, so hours. 1 hour, 2 hours, 3, 4, and 5. And then for distance, it goes up by increments of 12.5 each time, so I don't have to cut anything off. I can simply go 12.5, 25, 37.5, 50, and then, well, it only goes 5, 62.5. So plot the linear relation. So 1 hour is 12.5, 2 hours 25. Sorry, I know I didn't go that high. I'm limited only to what I can plot, but we get the idea. It is a linear relation. So now that we have all those plotted, the second part says B. From the graph, determine the approximate distance Sophie has cycled after 2.5 hours. So again, we're going to interpolate on our own graph. And midway between 25 and 37, we could say probably maybe roughly 30 kilometers or so. Right? We don't know exactly, but it's somewhere in between there. We're just guessing. We could actually do a calculation, but we're doing a quick thing. It's probably roughly 30, 31, 32, something like that. And from the graph, approximate how long it takes Sophie to go 44 kilometers. So I'm going to guess right around here is 44. And I'm going to say it takes roughly maybe 3 hours and 3/4 of an hour, so 45 minutes, roughly. So how long does it take? Roughly 3 hours, 45 minutes. Or 3 3/4 hours. Question 8, the graph shows a linear relation between distance and time. What is the approximate value of the D coordinate when T is 10? So when D is 10, if I go up here, I realize my line is gone. So I'm going to continue to extend my line. And then I'm going to extrapolate the answer. What is the approximate value of the D coordinate? I'm going to say roughly, maybe D is approximately, not quite 30, maybe 29 or so. If you said 30, that's fine, roughly. What is the approximate value of the T coordinate when D is 33? So again, I'm going to put 33 roughly here and go over. Oh, that's pretty easy. T is approximately 11. Question 9, again, same question. What's the y coordinate when x is negative 3? So when x is negative 3, I can go all the way up here, and I actually have my point right there. It looks to be roughly 15 and a half. So y might be approximately, it's not quite 50, it's a little bit more than 15, because 15 would be right in the middle of those 14 and 16. So maybe 15.5, 15.75, 15.6. You can take your guess, but 15.5 is pretty close. And what's the x coordinate? 1. Y is 1. So when y is 1, y1 is here. So in order for me to figure that out, I have to extend my line and meet it. And I can say x is approximately 3. Question 10, the graph shows a linear relation with the approximate value of the y coordinate when x is negative 4. So x negative 4 is right here. So in order to figure that out, I need to extend my line and extrapolate my answer. Oh, when x is negative 4, y is roughly 2.5 maybe. And when y is negative 6, again, I'm going to extend my line. When y is negative 6, that's pretty close to that. X is approximately positive 4. Question 11. Did I skip one? Maybe I didn't. It says, the table of values represents the drop in temperature after noon on a winter day. Plot the data on a graph. So when I make my two axes, again, I'm looking for my 1, 2, 3. And here I have a 1 o'clock, 2 o'clock, 3 o'clock. So I'm going to call this one T. Again, I'm going to call it time in hours. And I'm going to put a 1 hour, or 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, 5 o'clock. Or just 1 hour, 2 hours, 3 hours. So 1, 2, 3, 4, 5, 6, 7. for time in hours. Move this down a bit. And for temperature, ooh, look at that now. If we look at that, I realize that my temperature goes into the negatives. So I'm going to have to extend my y-axis, not only from positive range, but through negative as well. This is 1, so we're going to call this one temperature. And we're going to call it in degrees Celsius. So D for degrees, because time is already taken, the T is already taken. So we're going to call D for degrees. And that's 1, that's 0, that's -1, that's -2, that's -3, and that's -4. So once we have that, we can do 1 o'clock, it's 1 degree, or 1 hour, it's 1 degree. At 2 o'clock, it's 0. And I'm going to go through this, so I better move my time here over here. At 3 hours, it's -1. At 4 hours, it's -2. And at 5 hours, it's -3. So our graph looks like this. So from the graph, what is the approximate temperature at 6:30? So when I go down at 6:30 and meet this line here and go over here, according to my really poorly done graph, it appears that at 6:30, the temperature will be approximately -3.5 degrees Celsius. Now my graph has to be taken with a grain of salt because it is terrible. But if you did it on graph paper and were a little bit more precise with it, it would probably be a little bit more accurate as well. And then from the second C, from the graph, determine the approximate time when the temperature is 2 degrees. So I got to put 2 here. And the time when it was 0 degrees, or sorry, when it was 2 degrees, was at 0 hours. So since we're dealing with time here, not hours, it's actually 1 o'clock, 2 o'clock, 3 o'clock. The time would have been 12 o'clock. Question 12, in a bulk food store, blah, 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 blah. From the graph, approximate how much it is. So there are 2 ways you can do this. The first way, which asks you to do, is plot it on a graph. So I'm going to take this, shrink it down, and plot my data. So do I have any 1, 2, 3? Not this time. So here, I'm going to make this one the mass, which is the M, and the units are grams. Here I'm going to make this cost, and the units are dollars. So the good news is the spacing here is all the same. It's all up by $2.40. So it's going to be 240, it's going to be 480, it's going to be 720. I'm going to stop here because I'm lazy. 960. Going up here, the nice thing is it goes up by 250 each time, so I don't have to break up my line. Oh, I got it backwards. Oh, poopy darn. Why didn't someone stop me? Hang on a second. Let's try this again. I had my mass backwards. So mass in grams is 250 and 500 and 750 and 1,000 grams. And your cost is $2.40, is $4.80, is $7.20, and is $9.60. And the last one is $12 even. No, mass and cost. If you did it the other way, it's fine. It doesn't matter. But when you plot them, $2.50 for $2.40, $4.80 is 500 grams here and here. So our line is still on my graph is this. If you did it the other way where you had this is your cost and this is your mass, you could also have the same, you still have the same line, I believe. And it says from the graph, approximate how much 2,000 grams would be. So, oh, sugar cubes. My graph is too small. Hang on a second. Okay, my bad. So I have to extend this. So I got 1,250, 1,500, 1,750, 2,000. And I got to extend this so that I have 4 more here. And when I extend my line and I get my 2,000, which would be, this would be 250, 1,500 grams, 1,750 grams, 2,000 grams. When I extend it, I hit the line here. I go over here. And if I put my things up by $2.40 each time, this would be $14.40. This would be $16.80. This would be $19.20. and by 240, 21.60. So therefore, the approximate cost of the trail mix would be $21.60 by extrapolating the data. And from the graph, how much would $13 of trail mix roughly get you? So I'm going to go right around here, down, according to my crappy graph. $13 will get you approximately, I don't know, 1,350 grams of trail mix. And question 13, which I think is as far as I want to go today, because I think we're done after this. The submarine HMCS Victoria can dive to a depth of 200 meters. Is it reasonable to interpolate or extrapolate values on this? So is it possible that we could judge its depth here? Is that a reasonable thing to interpolate that piece of information? Yes, because it is possible to be at a certain depth at that time. Is it possible to extrapolate or go beyond here? It's as far as it can go to because it can only go to a depth of 200. And once we got to 200, it would no longer be a line. It would then level up because it's that as deep as it can go without exploding, right? So it's reasonable to interpolate but not extrapolate beyond the value of 200. And B says, how long does it take Victoria to reach a depth of 140 meters? If I extrapolate that and come down here, the answer is it would take 3.5 hours to reach a depth of 140 meters. And what is the submarine's depth after 4 minutes? Extrapolate that one as well. And after 4 minutes, it's roughly 150-ish meters below, or negative 150 meters below.